Okay, so when it comes to a hierarchy, you can get things called quadratic sequences, and quadratic sequences have a term n squared in them, so you've got this higher order term again. So it does make them more difficult. So we're going to look at an exam situation to learn what we do. Okay, so this was an exam question. So we got given the sequence 9, 13, 19 and 27, and it said find the next two terms. Okay, so what we do is, what have we done to get from 9 to 13? We've added 4. What have we done to get from 13 to 19? We've added 6. And 19 to 27, we've added 8. So as you can see here, this is what makes it harder. The differences are not the same. We're not adding by a step of 4 each time. The differences is changing. So that means for the next two terms here, instead of adding 8, we're going to add 8 plus 2, which is 10. So we know this term is going to be 37, and then instead of adding 10, we're going to add 10 plus 2, 12, so we're going to get 40, 7, 8, 9. So we found our next two terms to be this, so that was still okay. However, finding the nth term of the sequence becomes a bit harder. So I'm going to write out the steps we do, and then we're going to go through it. Okay, so these are the steps written a bit messily, so we're going to follow them once and then do a bit of practice, and then it should just be fine. So step 1 is find the difference of the differences. So I quite like this. So we knew the difference here is 4, 6 and 8. So the difference of the differences there is 2 and 2. So we can work out the difference of the differences, so DOD I'm going to call it, is 2. You then divide by 2, and this becomes your n squared coefficient. So you know it's a quadratic sequence because the difference is changing, it's not linear. So difference of the differences is 2, and then we divide that by 2, so DOD divided by 2, 2 divided by 2 is 1. And this is your n squared coefficient, so you know you're going to have n squared. Okay, so step 2 is take your original sequence and subtract the sequence you did in part 1. So my original sequence I'm going to rewrite is 9, 13, 19 and 27 over original. Then I'm going to do my n squared sequence that I found here. So this could be, because the coefficient was 1, it's n squared. If my coefficient was 2, we'd be doing 2n squared. So n squared, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Subtract the original sequence, subtract this new sequence. We do a subtraction. So 9 take away 1 is 8. 13 take away 4 is 9. 19 take away 9 is 10. And 27 take away 16 is 11. Part 3. Find new sequence, so the nth term of the sequence, for the one in part 2. So now we look at this sequence and we find the nth term of the sequence for this, and this is now, this was the point of doing this, this is now no longer quadratic, so it's like the ones we were doing before. So the difference here is 1, 1, 1, so you know you're going to have just n with a 1 in front, but you don't have to write that. But if we looked at the sequence just n, you would have 1, 2, 3, 4. So how much have we shuffled? So what do we add here? We've shuffled it along 7, so 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10. So we've shuffled it along 7. Part 4, add them together. So we take this, and we take this, and we add them together, n squared plus n plus 7, and that is our final answer. So I'm just going to run through the steps, and again, before we move on to another example. So step 1 is find the difference of the differences and divide by 2. This becomes your n squared coefficient. Part 2 is you take your original sequence, the one here, and you subtract this sequence you found. So in our example, this was n squared. Then you find the expression for the nth term of this new sequence. Part 4, add this part, and there's your answer. So let's do this again with a different example. Okay, so this was an exam question, so we'll do this before doing more calculating more quadratic nth terms. So the nth term of the sequence is 2n squared plus 4n minus 1. What is the 10th term? So we know this is a quadratic sequence because it has this term here. So the 10th term is when n is equal to 10. So if we substitute n equals 10 in here, we have 2, 10 squared plus 4, n, but n is now 10, minus 1. So that is 239. Okay, so find the expression for the nth term of this sequence, so 2, 10, 22, 38. So first of all, we're going to look at, is it a normal, is it a quadratic sequence? So what's the difference here? We have a difference of 8. From 10 to 22, we're adding 12. So the step one is find that, we can realise that's now not a linear situation because the differences are different. So what about the differences of the differences? So to get from 8 to 12, we add 4. And 12, 13, 14, 15, 16, we add 4. So the difference of the differences, so part 1, DOD, is 4. So in part 1, we know we have to do the differences of the differences divided by 2. So 4 divided by 2, which is 2. And this becomes our n squared coefficient. So we know we're going to have 2n squared something. Okay, now we move on to part 2, and that is taking your original sequence and subtracting your new sequence, which is this. So we have 2, and we're going to subtract the sequence 2n squared. So n squared, so 1 squared is 1, times 2 is 2. 2 squared is 4, times 2 is 8. 3 squared is 9, times 2 is 18. And 4 squared is 16, times 2 is 32. Okay, so let's do this. So 2 minus 2 is 0. 10 minus 8 is 2. 22 minus 18 is 4. And 38 minus 32 is 6. Okay, so part 3, find the new nth term of the sequence for this. Okay, so what's the difference? We're going add 2 there, add 2 there, add 2 there. So we know we're going to have 2n. But let's look at the sequence 2n. So that was going to be, if we started with 1, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. So now we're going to take a look and compare these numbers. We've got this sequence but shuffled. So we're trying to work out the shuffle, this term here. So instead of 2 we've got 0, instead of 4 we've got 2. So 2, so I think it's subtract 2 because 2 minus 2 is 0, 4 minus 2 is 2, 6 minus 2 is 4, and 8 minus 2 is 6. So part 4, this is the easy part, we add them together, so our answer is this part plus this part, so 2n squared plus 2n minus 2. And that is your answer. So we're going to do another one of those. Okay, so find the expression for the nth term of the sequence 2, 10, 24, 44. So okay, let's just look at the differences like we would for any sequence. That is going plus 8. So we can immediately see this relationship is non-linear. It must be a quadratic sequence because the difference of the differences is different. So first we need to find the first step, find the difference of the differences. So here we've gone from 8 to 14. So 8, 9, 10, 11, 12, 13, 14. That's gone up by 6. 14 to 20 has also gone up by 6. We've calculated the difference of the differences to be 6. We take the differences of the differences and we divide them by 2. So that is 6 divided by 2, which is 3. Now this becomes your n squared coefficient. So we know we're going to have 3n squared in our sequence. Now we do step 2 and we take our original sequence. So 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. Ooh, looks like we're going to have some negative numbers. Right, let's calculate this. So 2 subtract 3 is negative 1. 10 subtract 2 is negative 2. 24 subtract 27 is negative 3. And 44 subtract 48, 44 subtract 48 is negative 4. Okay, so this is our new sequence. Now we want to find the nth term of this sequence. So let's look at the difference. The difference is we're subtracting 1, subtracting 1, subtracting 1. So our coefficient for our n, this is non-quadratic because they're all linear, is minus 1, so minus n. But now we need to check our shuffle term. So if we just write the term minus n underneath, you would have minus n would be 1, minus 2, minus 3, minus 4, etc. Now as we can see when we compare these numbers are exactly the same, so we haven't actually shuffled, so we don't need a term here. So now we need to part 4, add them together, we found this bit and this bit, so our answer is 3n squared minus n. Okay, so this question has two parts. We've been given a sequence, minus 8, 2, 16 and 34, and it says part A, show that the nth term of the sequence is 2n squared plus 4n minus 14. So basically we're going to work out what we've just been doing and then hope that we get the same answer, otherwise try again. And then part B, hence find if 272 is a term in the sequence. You make it equal that and you solve for n and you hope if n is a whole number it is, if n is not a whole number then it is not. First things first, let's look at this sequence and find the expression for the nth term and then hope it's the same as this. So first, what are the differences? Okay, so what is the difference of the differences? We've gone 10, 14, 18, so we're adding 4. So part 1, we take the difference of the differences and we divide them by 2. Difference of the differences is 4, divided by 2 is 2. And this becomes our n squared coefficient, so we know we're going to have 2n squared. Okay, so now we're on to step 2. That's fine. So we take our original sequence, step 2, our new sequence, which is 2n squared. So what is 2n squared? So when n is 1, you get 1 squared times 2 is 2. Okay, so now we do the subtraction. So the original one subtract the new one. Minus 8 minus 2 gives minus 10. 2 subtract 8 gives me minus 6. 16 subtract 18, so 16 subtract 18 gives me negative 2. And 32 subtract 32 gives me 0. Okay, so part 3, we find, part 3 here, we find the new sequence for the one we've just created. So we're looking at this, and now we want the expression for the nth term of the sequence, and hopefully this should now be non-quadratic. So let's look at the differences. We have, now this term we wouldn't be adding 4, so I'm going to go with that I've made a mistake. So I'm going to look at this again. And that is because I've written 32 instead of 34 from here. Okay, so now we'll change this. 34 minus 32, and that's going to give me plus 2. Okay, so now we've sorted that out, we can continue looking at our sequence, and yes, that is plus 4. Okie dokie, so we know that this is a linear relationship because it's the difference is the same each time, and we take that form and put that as a coefficient of n. But now we compare this sequence to the sequence for n because we want to see if it's like shuffled along any at all. So when n is 1, we have 4 times 1, which is 4. So what is the difference here? How long have we shuffled? So if we look at this, we're hoping it's minus 14. So let's do 4 minus 14. Yes, that is minus 10. 8 minus 14. Yes, that is minus 6. 12 minus 14 is minus 2, and 16 minus 14 is that. So we know we've shuffled it by minus 14. Step 4, which is our final step, is putting this together. So we have 2n squared plus 4n minus 14. And bingo, we've shown what it asked us to show. It is important to know that for part B, you don't actually have to have done part A, so don't just give up on a question entirely if you're having difficulty. So hence find if 272 is a term in the sequence. So what we do here is we take our nth term of the sequence, our expression for the nth term, and we equal it to the value in question. Now we try and solve this. So I'm going to bring this over here because I know it's quadratic, so I'm doing quadratic sequences, so I'm going to have to solve a quadratic if I'm solving this equation. And that gives me that. I'm going to use the quadratic formula because I can't be bothered to find numbers that add and multiply to that. So we're going to go straight to the quadratic formula. Whoopee. So first let's identify A, B and C. A is this term, the one of the coefficient, the number before the squared term, so that's 2. B is 1 before n, and C is minus 286. So we're now going to substitute those numbers into our equation. So n is equal to minus b, minus Okay, so then you plonk that in your calculator and you hope that n is a whole number. So I'm going to do the plus one first and get back to you. The answer when I do take the plus value is n equals 11, so that's looking very promising. Let me just do the minus value, and I get n is equal to minus 13. So the question is, hence find if this 272 is a term in our sequence. Now we're not going to take negative numbers because n is going to be values like 1, 2, 3, 4, it's a term in our sequence, positive values. But yeah, 11, we can take 11 as an n value, it's a positive integer. So yes, 727 is a term, and in fact we can identify it the 11th term in the sequence.